Everyone, welcome back to Baozi Training Leetcode solution. If you want the best software engineer mock interview in North America, feel free to check us out at baozitraining.org, and also feel free to subscribe to our WeChat blog. Well, everything will be in Chinese. We're here to help you land your next big offer. So today we're going to talk about a problem which is Leetcode 208 implement a tree or a trie. So actually it's pretty interesting how do you pronounce this word. You see people pronounce it either tree or try. So I think phonetically this should be pronounced as a tree. Phonetically should be pronounced as a tree, I guess, but people don't pronounce it as a tree because it will be confusing whether it's a tree. Like, do you mean actually a tree or a prefix tree? So normally we just pronounce it as try. Anyways, minor details. So we actually, this is just the most basic data structure, right? So it actually is a very frequent one. I personally got asked this at my Fitbit interview, Snap interview, and also Google interview back in 2016, I think. So I highly recommend everybody to brush up this data structure. It's actually very, very simple. And Leetcode actually did a great job of just explaining this one. So essentially, I'm gonna just go with this. So you can actually download it from this blog right here. So I actually posted here. I posted it here. So feel free to click on this, and then you will see the PDF file. So first of all, it's actually quite interesting. So, when the autocomplete will use prefix tree, and the spell checker will also use prefix tree to check your spellings, and the IP routing, choose the nearest longest prefix matching, the T9 predictive text, if you remember back in the days, right? So people normally type in those kind of things like the T9 input method, and also the Boggle game. So the longest word has the, let's say, 6-letter words has 5 points. You just get the words from here. Yeah, it's actually, like I said, it's a very simple data structure. The way it works is Leetcode uses the word leet in this example. So every letter is essentially a node, right? So, and then for this example, you have like 26 letters. So normally you can allocate a 256, which is the ASCII length, or you can just keep a hash map. I personally just like to keep a hash map. So the first word is L. So what I normally like to do is also keep a dummy node. So it's kind of like when you do linked lists, right? You have a dummy node and then you have the actual node. So it's end? No, because it's not the end of the word. So you have L, E, E, T, and then you have is end equals to true. So that field. Yeah, they basically explain this, and then insertion of a key to a tree is essentially one by one. So the only two cases, right? If the link, which means if the character already exists, so you just keep searching, or else you create one and then just create the rest of the string. So essentially it's ON time complexity and ON space complexity, and in terms of the word length. And then we talk about the search. So search is essentially just coming from the root and then search it one by one. But just note the search is actually exact matching. So if the end is not, it has to be the end, or else you only search part of the string. So you should return false. And then the search for a key prefix is essentially the same as search, but you don't need to check the is end whether equals to true or not. That's it. It's actually very, very simple problem. You have to write this problem, I think, in about like 10 minutes. So this is my implementation. I also have a previous blog talk about a modified version, which is add and search, where you can do a little bit like a fuzzy search, like a dot can represent one and exactly one letter. So here's how I implemented it. So it's quite straightforward. You have a tree node, and then I use a hash table, use a character instead of actually array, which is totally fine too. So I keep a dummy root. So this is essentially my dummy node. So whenever you insert, so I did some additional check, which this problem says you don't need to, but I always do that. So the current is the root, and then one by one, if it does not contains this one, you actually have to create a new tree node, and then you add it to there. Yeah, I think that's all I need here. New hash map. Wait a sec. How did I actually create this tree node? Let me see. So this character letter equals something. Char current children dot put. Okay, so you already have the current one. Then you have to put the children C, and then oh, this is just create the children. It's children, which is a node. So it's actually C. Okay, this is a search. This is a start with. I mean, the time complexity, like I said, everything is here. Yeah, I guess the only tricky part of this problem is actually how do you pronounce it, is whether a tree or a try. Up to you. Thank you very much. Till next time. Bye.